Question 18. Which of these following complex numbers is equal to 3 minus I over 2 plus I? Note, I equals square root of -1. This is not really hard. This is division under complex numbers. We have 3 minus I over 2 plus I. Similar to swords, all you simply need to do is to multiply both the numerator and the denominator by the conjugate of the denominator. Since the denominator, that's the number below, is 2 plus I, the conjugate of the denominator will be 2 minus I. So we multiply both the denominator and the numerator by 2 minus I. We have times 2 minus I times 2 minus I. You have a division sign in between. We can write this as 3 minus I in brackets 2 minus I in second bracket over 2 plus I in one bracket 2 minus I in second bracket. Note this point. When you multiply a complex number by its conjugate, the result is always a real number. That is a value without I. It's like in swords. When you multiply the denominator of a sword by its conjugate, you get a number that doesn't carry square roots. Similarly, in this case, the result doesn't have I. We've moved it to this side so we can have more space to solve. We have this equals to 2 minus I twice, leaving space in between them. The first 2 minus I gets the 3, and the second 2 minus I gets the minus I. You have to take the I with the negative sign in front of it. Negative I. Then over. For the denominator, if you're very good with difference of two squares, you know the base is a difference of two squares. That is, you have a square minus b square is same thing as a plus b in brackets, then a minus b in the second bracket. You have 2 plus I and 2 minus I. That one has a positive, the other has a negative, the same values, except for the signs in the middle. Same as this. Meaning that you can get this to look like this. That your A is 2 and your B is I. So you can have 2 square minus, this carries a negative. Your I is B. You have I square. This will give you 2 square is 2 times 2. That's 4 minus I square. From previous questions, you should know I square is minus 1. Because I equals the square root of -1. Let's write it out. I equals square root of -1. If you square the I, you also have to square the square root of -1. The square cancels the square root. So I square equals -1. So you should know this is -1. So you have 4 minus, there's a negative here first, then also -1. Because I square is -1. And when you have two negative signs together, you have to resolve them into one. That negative times negative will give you positive. So we have 4 plus 1, which will give us 5. If you are very good with this method, you will save more time. But if you're not, you can expand the normal way, where you can choose to repeat this 2 minus I twice. You have 2 minus I, and you have 2 minus imaginary number I. The first 2 minus I gets this 2. The second one gets this plus I. You have plus I. Next we multiply. We have 3 times 2. That will give you 6. Then 3 times minus I. That will give you minus 3I. Then you have minus I times 2. The 2 has a positive. That positive times negative will give you negative. 2 times I will give you 2I. Here is where you need to be careful. You have minus I times minus I. This I carries a negative. This also carries a negative. So you have negative times negative will give you positive. Then I times I will give you I square. That done, you have over 2 times 2, that's 4. This 2 carries a positive, and when it's positive, it's not really dangerous. It's negative that actually causes issues. So you have positive times negative will give you the same negative you have here. Then 2 times I will give you 2I. Then you have plus I times 2. That will give you plus 2I. Then you have plus I times minus I. Start with the signs first. Positive times negative will give you negative. Then I times I will give you I square. We have this. We can further simplify. Let's go to the numerator. We have 6. Then you have minus 3i minus 2i. These are like terms. It's not like term with this I to the power of 2. This has a power of 2. These other two values have a power of 1. So they are not like terms. Note that. So we have minus 3i minus 2i is like saying minus 3a minus 2a. Just like you do in algebra. Same applies to this. The negative means you're owing 3 and you're owing 2. In total, you're owing 5. And if you're owing, it's a negative. So you have negative 5i plus, you can convert I square to its numerical value, which is negative 1. So we have this as negative 1 over the denominator, which is 4. You can put this in brackets. You have minus 2i plus 2i. You owe 2, you have 2. If you pay the 2 you owe with the 2 you have, you would have nothing left. So minus 2i plus 2i gives you 0. Then you have minus, you have to be very careful here. There's still a negative here. Note, this I square owns this negative. You can now convert this I square to its numerical value, which is negative 1. So you have in brackets negative 1. This is equal to 6 minus 5i. Then you have positive times negative, or positive and negative, two different signs gives you a negative. You have negative 1 over 4. You have negative and negative. Negative times negative gives you positive 1. This equals 6 minus 1 minus 5i. You collect like terms at the numerator. That's this 1 owns this negative. You move it back to meet with the 6. At the denominator, you have 4 plus 1, that's 5. Let's solve down. We have 6 minus 1, that will give you 5. You have 5 minus 5i over 5. Now, this is not the final answer. It's like having 6 over 2. You can't leave this as your final answer. You have to simplify it. That's 2 here 1, 2 in 6, that's 3. Same applies to this. It's either you go this way, since they are linked by negative, or if they are also linked by positive, this method you apply. But if they are linked by multiplication, you just say 5 in 5, 1, 5 in this 5, 1. But they are linked by subtraction. So it's either you factorize, or you give each of them their separate 5s. That is, you have 5 over 5 minus 5i over 5. Here you can say 5 in 5, you have 1 minus 5 will cancel 5, you'll be left with I. That your answer is 1 minus I. That's the answer to this question. Or from here, let's write it here. You have 5 minus 5i over 5. You can factorize at the numerator. They both have 5, so you take out 5, you'll be left with 1. Because if you take out this 5 from this 5, you'll be left with 1. And this 5 from this minus 5i, you have minus 5i divided by 5. 5 cancels 5. You'll be left with minus I. So you have minus I, close bracket, over 5. This 5 cancels this 5. You'll be left with 1 minus I. The same answer, two different methods. So the answer to this question is B. That's 1 minus I. Hope you understand. In summary, there are two major steps in solving this question. The first step is multiplying both the numerator and the denominator by the conjugate of the denominator. The next major step is just to simplify until you get to your answer, which is 1 minus I. That's simple.